Hi, this is Mrs. Marita. Welcome to section 6.2, exponents and exponential functions. This video is part one of a two-part series, and today we're going to focus on key features of exponents and exponential functions. This will include some graphing and estimation with tables and some technology. So here we go.
Hi class, we're going to be going into lesson 6.2. For lesson 6.2, we're going to be on page 120 of your workbook. So on your workbook, it's going to be an extension of the examples that you're going to see on your screen, which is why I'm doing this on computer. All right, so we're going to be on page 120. We'll go to our first example here now, okay? So we're going to skip through the explore and reason, and we're going to go straight to example 1. And there's a couple of key features that we're going to look at first. The first thing is we're going to look at this graph that says f of x equals 2 to the x power. This is what we call an exponential or exponential function, okay? So when we talk about exponential functions, it's going to be an exponential, an exponent here. So it's going to be an exponential function. And so we're going to look at this solution here, and we're going to look at the different things that we're going to be talking about here. The first thing is that this is an exponential graph, okay, where it goes like this, and this is what you call exponential growth. In this case, it would be, a real life example would be the number of coronavirus cases, right? It's growing exponentially, so we're going to see this skyrocket of everything. Another example would be like a Bitcoin price, right? If you guys see the price of Bitcoin right now, it's skyrocketing and it's growing exponentially, right? So the things that we're going to talk about when we're talking about an exponential graph is we're going to look at things such as the x value approaches blank, y value is going where. So the first thing that, or one of the features that we're going to be talking about, as x approaches negative infinity, where is y going? And as x approaches positive infinity, where is y going? Okay, so those are the two answers, or those are the two questions that we're going to look at as well. We're going to look at the domain, and we're also going to look at the y-intercept. Where is the y-intercept located? Okay. And then where is the asymptote as well? Okay. So let's go ahead, and if you're taking notes, this would be a good thing to write down. But first, let's look at the first example of 2x and see the answer to the question, okay? As the x values are going to positive infinity, what's happening to your y values? Your y values are increasing towards positive infinity. Y is approaching positive infinity, okay? For the top one, it says as x is approaching negative infinity. So what's happening to your y values as x is going this way? Your y values are heading down towards 0, but it actually doesn't hit 0. So we're going to go ahead and put your y values are heading towards 0, okay? The next thing we're going to look at is the domain, all right? The domain, well, for this graph, it goes all the way to your left and it keeps going right, okay? So we're going to go ahead and write all real numbers for your domain there, okay? It's getting a little messy on my graph, so I'm going to go ahead and erase some of these things, okay? So we have our domain. We know how to find that from our earlier lessons. And then we have our y-intercept. Well, the y-intercept is where the graph crosses the y-axis. It's very easily put. It's 0, 1, okay? And so there we have our y-intercept. The last thing we're going to talk about is an asymptote. An asymptote is the line in which the graph never crosses. We know that this graph always goes this way, or will continue to go this way. It continues to run this way, but it will actually never cross this line right here of y equals 0. So in that case, our asymptote is going to be y equals 0. Okay? And so these are the different features of our exponential function that we're going to be able to identify. Let's go to your first example in your book. So in your try it question on page 120, okay, it says identify the key features of the function f of x equals b to the x for b equals 2 and b equals 1/2. So what we're going to do is let's create a t-chart on your page 120, okay? And on one side of it, we're going to go ahead and write f of x is equal to, let's plug in for b equals 2 into the equation, or into the function. So that gives you 2 to the x power. On the other side, we're going to do f of x is equal to 1/2 to the x power, like that. Okay, so these are the two functions that we're going to be comparing and contrasting and identifying the key features for each. Okay, so if I go to this Desmos graphing calculator, thankfully I can just plug it in. F of x is equal to 2 caret, that's going to be shift the number 6, x. Okay, so now I have a red graph that comes like this. Okay, the next one would be f of x is equal to 1 over 2 all to the power of x. And so now I have a black graph that comes down like this. Okay, let's identify the key features. We know that the y-intercept is located at 0, 1. So I'm going to go ahead and write y-intercept for both graphs is at 0, 1. Okay, 0, 1. All right, nice. So we have that one done. What about the domain for both graphs? Okay, for the red one, it goes all the way through and it keeps going this way, and it keeps going to the left. So that's going to be in all real numbers. So that one's solid. We're good. The next one is going to be the black line where it goes to your left side and it goes to your right side. So it goes this way and it goes this way. So then the domain is going to be all real numbers as well. Okay. And then we talk about the asymptote, the line in which the graph does not cross. Okay, so I'm going to spell out the whole word asymptote here. And if I were to look at that, I'm going to go ahead and erase this. The graph does not cross this line right here. Okay, the graph does not cross this line. So if that's the case, that's the equation of that line is y equals 0. So that's going to be that for this one as well as this one, because both graphs do not cross y equals 0. So there's my asymptote. Okay. And then the last thing is as x approaches positive infinity and as x approaches negative infinity, what's happening to your y values? Okay. Where is y going? Okay. And the same goes here. As x is going to positive infinity, where is y going? As x is going to negative infinity, where is y going? Okay, so let's answer that question for the 2x graph first. My 2x graph is this red one, right? So I'm going to go ahead and erase the y equals 0 because we know that that's the asymptote. So for the red graph, as x is going to positive infinity, okay, so for the red graph, as x is going to positive infinity, so as x is going this way, what's happening to your y values? Your y values are going up. Okay, so we're going to go ahead and put that it's going to positive infinity. Okay. And then for the red graph, I'm going to go ahead and erase this. As x is going to negative infinity, so as x values are negative, so as your x values are going this way, what's happening to your y values? Well, your y values are heading down towards 0. Okay, so they're going to be heading towards 0. For the black graph, okay, as x is heading towards positive infinity, so as your x values are going this way, it's going to be different now because your x value and your y values are coming down towards 0. Okay, so we're going to go ahead and put that as x is going to positive infinity, now this one is going to 0. And then as x is going to negative infinity, which means that as your x values are going this way, what's happening to your y values? Your y values are increasing towards positive infinity, okay? This is a portion that is confusing and it takes a lot of practice. So I would copy it down and then ask questions when you get there, okay? So that's example 1. Try it in your book.
And that's it for 6.2 part 1. Make sure you copy down all your notes and bring your questions to class.